Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk a little bit more about volatility. So first of all, what is volatility anyway? Well, it's an open source tool for examining memory dumps. And it allows you to examine Windows memory dumps, Linux memory dumps, and also Mac memory dumps. So I just browsed on over here to their page. It's volatilityfoundation.org. If you look at their page, you'll see they have references to the most recent version of volatility, which was released with a really good book, The Art of Memory Forensics. We're just going to hit some of the highlights of using volatility in this class. If you want to go a little further in depth, maybe some of the topics that we don't cover, in particular, we will not be covering Mac or Windows in this particular course. You might want to browse on over there, consider picking up a copy of their book, and kind of go from there. So back to our situation. We have a memory image, which we stored a long time ago. And so what we need to do is we need to take and run volatility. So how do you do that? Well, it's vol.py, and then you just run it. And if you give it the option --info, it will print a bunch of stuff. If you pipe that to grep on Linux, you should get a list of a couple of your plugins, and I do. Here we have it. We have two profiles. One of them is for a slightly different kernel, the -30 kernel, and the other one is -34. -34 is for my Linux system that I'm running this on, and -30 is something we built using our script from a previous video. So if I want to run volatility, I run vol.py --profile equals, and I'm lazy, so I'm going to copy and paste this right here, and -f, our image. My images are stored under cases. And here I have a ram.lime file. We talked about how we got this file in a previous video. And then I need a command. So I will start out by typing the command linux_pslist. Please give me a process list. And here we have it. There are a couple of error messages about some plugins that it couldn't load, which actually don't affect us in our case. So if we look, we'll see our offset, the name of the process, its process ID, user ID, group ID, DTB, start time. So of course, init is process 1, which is owned by root, and then we see a bunch of other system processes. We see a thread process, some workers, a watchdog, etc. So we can see all these system processes being started. Then we see there are a few things being started by non-root users. And here, that's an interesting process. It's been started by the user 64K. It's an interesting user ID. And here we have our normal user. Our first normal user is usually 1000, and they've started a bunch of processes. And if we continue through this list, eventually we get to some interesting things like this. Notice this first process, Xingxi bind shell. So yep, sure enough, we have a rootkit process that's being run as root. Someone ran sudo and bash, and they have a root shell open, and we have a few other things as well. So that's how you use volatility. It's pretty simple. It's a little bit annoying sometimes because of these profile strings. Something you could consider doing with volatility. You could consider taking all of this junk and creating an alias. So you might just copy that and then perhaps in your bash file, your bash RC file, or somewhere else. And I'm going to edit my bash RC, and I'll just go to the end and add another alias. You can see that I already have one to update my system. And I'll say this one will be vol for Pentester Academy equals, in quotes, I'm going to add my string like so, and I'll write my file. Resource it, and now I can do something like this: VPA Linux underscore PS tree, and I get a different kind of display. So here I will get a process tree that is displayed for me. So now I'll run a process tree, and here I have my process tree displayed. And the way that this is done in volatility is I have periods that show a process that is a subprocess of something else. So you can see here I have a couple of subprocesses of the network manager, and there's a few a little lower down that have many levels. In particular, if I look at LightDM, which is a windowing manager, I will see that it has a bunch of sub-processes running. Of course, I could take this output and pipe it to grep, shing, shi, and sure enough, there I have it, my shing, shi bind shell. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.